Okay, so this is Justin for the second Sprint 4 engine. So first I'll go ahead and show that everything is working. So the AABBs are here. You can see AABB and AABB collision are working. And then, so you can see that they're turning red when they run into each other. And that also, as I'm turning the tank, it's aligning itself properly. So then I've also got a sphere. You can see when I'm running into that. Yeah, I'll kill this thing real fast. It's getting in the way. You can see, okay, forget it. The sphere works with the AABB, and it also works going from the box to the sphere and then the sphere to the box. So that's all good there. So then going through it here, there was a lot of stuff to change. So the first thing was fixing that ridiculous memory leak in our visualizer. So I talked with Mikhail, and he had showed me a way to kind of fix that. So before we were just using a unit sphere collection, or sorry, a graphics object collection here, pushing that, or creating new spheres, pushing it into that, and then rendering that at the end of the frame. But instead, he had showed me a way to switch it to two different lists, one for AABBs and one for B spheres, and kind of doing an object pool with that, so having both a submitted list, so one that's going to be drawn during that frame, and then a list of recycled objects, so ones that could be called upon later. So going through that, here in the show B sphere and now show AABB, this used to be where we were creating, where I was creating new spheres over and over, so that's gone now. Now instead it just calls this submit render B sphere, which if the recycled command list is empty, it's going to create a new one, a new command, not a new sphere, which is just a world position and a color, and push that back into the list so that at the end of the frame that can be that can send the B sphere, or in this case AABB, to the correct location and color and draw it there. Otherwise, if this recycled list is not empty, it will just, or sorry, if that is empty, it will pull one from the recycled list and set it to the submitted list to be drawn. So that was the updates first with that, with the visualizer. Also with the show B sphere. Let's see. Oh, sorry. Yeah, this was just submitting the command for it. This was the actual setting of the position. So that's different now. That should be all good. Show collision volume is now in. So instead of calling the show B sphere, it now does the it now figures out which one to get. With this debug view here, it'll pick between these. So if we go to the AABB debug view, it'll now call the show AABB, and it will do all of the correct math and everything. So that should be good. Next up was the collidable. So now I have the set collider model instead of the, let's see, I'll do the .h first. So before we had the B sphere, now we have the generic collision volume here, and also a volume type. I had put this in early. I don't think I actually need this here stored in the collidable, so I'll take that out. But it's just used when setting the collider model, so I think that's okay. But anyways, just for setting the collider model, I think you'd said that it was okay if we just used basically a switch statement just to create the initial volume for that generic type here. So I guess I think that's okay. If not, I'm sure you'll let me know. But so that's just setting up the collider model. But other than that, it's just almost the same, just with this stuck in here. I do believe that's all good here. The update collision data is the same thing. So instead of the update B sphere, we now have the generic one, which can switch between the AABB or the B sphere. And then inside of these now, I've created new math tool functions. So compute B sphere and also the compute AABB. So instead of having all the math here, that's now over in the math tools, which I'll get to in just a second. But so that should be good for the collision volume B sphere and everything. The collision test commands are also different. So we took out all of the unnecessary stuff, and now we just have the math tools intersect with the generic types here. So now if we go to this, it now gets to pick between all of the new B sphere to AABB, or whatever it may be. So that's all good for that now. Let's see. Believe went over this. Yeah. So this is the same thing as the B sphere. Same thing with the math tools. Compute AABB. There's the corner min and max that's stored here. That should be fine. Of course, for both the AABB collision volume and the B sphere collision volume, it's got all of the different intersect functions associated with that. I believe I already went over this. Yes. So collidable's all good. Trying to remember if there was things for that. No. Went over visualizers. That's all good. And then of course just the collision volume base. Just created one of these with the different intersects put into it, and the compute data and the debug view. Lastly, I'll go to the math tools real fast and show what's in this. I don't think this is everything that you had, so I probably need to go back and add a couple more, but this should be at least the important ones. So all the intersects for all of those, and then I've got the compute AABB and compute B sphere. If there's any that I obviously missed, please do let me know, because I was kind of scratching my head on what I had seen your slide where you had 15 different functions in here. And then I'll just go to this real fast so you can see what we did in here. So the intersect for B sphere to B sphere is the exact same. The intersect from the AABBs to AABBs was this. Surprisingly, this one actually took a while to figure out. Went back to the good old math notes from a couple quarters ago and finally got that to work. I actually did this one first, and I thought this was a lot, and then I realized that when I got to the AABBs to B spheres, this one was actually the one that required a little bit more work. So all of this is here, just getting the squared distance first, checking the x, y, and z, and then seeing if the squared distance was in fact greater than 0 after all of the checks. So that's all good. And then the B sphere to AABB is the same thing. The only difference is that the two types that were taken in were switched. So that one was pretty easy. Other than that, oh yeah, and then the compute AABB was also the same thing. So, and compute B sphere is the same. So that's all good for that, I do believe. Lastly was the extra thing that we're working on. So I definitely want to have sound. I also would like to do some 3D sound. I believe I can't remember exactly what you said, but I'm pretty sure that 3D sound was enough to fill everything we need to do. If it's not, then I will probably look up some sort of easy state machine or something I can do for simple AI, if this isn't enough. But if doing all this 3D sound is enough, then I'd like to work with this. So I would be using Fmod. So I was going through some of the documentation for it and just kind of looking at everything that I needed to have for it, and it looks like it's definitely possible. They have pretty good documentation for everything, and they even have like a little demo thing here, which is just a simple C++ script that has a main function that will basically go through, load in the files. Where was it? Load in the files here. And then play the sounds at different positions in the world, and then this is all hooked up through this would be a game loop basically, and then finally deleting the sounds over here. So definitely I want to do 3D sound with roll off and possibly the Doppler effect, I think it's called. And multiple 3D sounds. So I believe, actually I don't believe it's in this one. I had been looking up some other stuff on it, but so this isn't in my engine yet. I'm going to be working on this this next week, obviously. But this is just like a simple demo thing that I can start looking at to get in my engine. So yeah, 3D sound, and if needed, simple AI stuff that I would also need to research is what I'd like to work on. Thanks.